Good morning, kids. I hope everybody is staying safe at home. Welcome back to the course of High Voltage Engineering. We are on to unit number 4, which deals with testing of equipment that are used in high voltage engineering. As we see, the different equipment that are commonly employed to withstand high voltages are the first one being the insulators, overhead insulators. The second one, the transformers and the bushings. The third one being the isolators and the circuit breakers. Number 4 being the surge diverters. And number 5 being the cables. So all these 5 equipment are there in your syllabus in your unit number 4. So we will see the different tests that are conducted on these equipment before bringing them into field. In the last class, we have discussed about the terminology of the different tests which are conducted on high voltage equipment. We have seen what is meant by flashover voltage, withstand voltage, creep page distance, etc. And also we have seen the differences between the type tests and the routine tests. In the present lecture, we will be discussing the different tests that are conducted on insulators. I hope by the end of this lecture, you will be able to list the different tests that are conducted on insulators along with the pollution tests and explain their procedure. Moving ahead, you might have come across these insulators in your course of Power Systems 1, where you might have classified these insulators based upon their structures and utilization. There are different types of insulators in markets based upon their operating voltages, structure, and their applications. The commonly employed insulators are pin insulators, suspension insulators, shack insulators, strain insulators, post insulators, which are generally employed in railways, and bushings, which are generally employed in transformers. So all these are different types of insulators. All these insulators are mostly made up of porcelain, or what we call it as ceramic, and glass. Glass is being extensively used for making of insulators in Europe and North America. Nowadays, composite insulators are there in the market. In the future, we hope that the entire insulators will be replaced, the porcelain glass insulators will be replaced by composite insulators because of their adaptability and flexibility. Now, shown on the figures, the left side you can see a glass insulator, and on the right side you can see a flashover which is being experienced when you are testing an insulator. Now, moving on to the testing of insulators, these are the different tests which are conducted on insulators, broadly classified as power frequency tests, that means which are to be conducted on power frequency voltages. And the second classification is impulse tests, which means your insulators are subjected to impulse voltages. And the last one is pollution testing, which is exclusively done only on insulators. Pollution testing. We will see all these things in this video lecture. The first one being the power frequency tests, where the insulators are subjected to power frequency voltages. There are two types of power frequency tests which are conducted on insulators. The first one is a flashover test and the other one is a withstand test. And both these tests are to be conducted in two conditions, the dry conditions and wet conditions. Why dry and wet? As you see, the overhead insulators mostly they will be outdoor units, and so they will be experiencing dry conditions and also wet conditions. During rainfall, there will be layers of water vapor, or the atmosphere will be humid in nature, and thereby there may be a chance of lowering of your dielectric strength. So your insulator must be tested for both dry conditions and also wet conditions which do happen in the fields. Now, the question always arises how to create the wet conditions in the laboratories for testing of your insulators. There is a standard procedure for creating wet conditions in the laboratories for testing of insulators. The aim is not to reproduce the actual operating conditions, but to provide a criterion based on experience that a satisfactory service operation will be obtained. And the standard procedure is very simple. You take the insulator specimen and the water will be sprayed onto the insulator at 45 degrees angle from the vertical. And this spraying of water will be started 1 minute prior to the application of voltage, at least 1 minute. And this spraying of water will be continued onto this insulator during your application of voltage. So the same has been mentioned there. See the procedure, the spraying of water of given conductivity by means of nozzles to replicate the rain. So small droplets of water from nozzles. It will be sprayed onto your specimen and the water drops will be arranged such that they will be sprayed at 45 degrees angle to the vertical, and they must be sprayed for at least 1 minute before the voltage application, and they will be continued during the voltage application. So this, along with this, there is a specifications of wet conditions as per the standards. See the precipitation rate, the direction of waterfall, and the conductivity of water, and the water temperature. These must be as per the standards. So you are supposed to test your equipment for both dry and wet conditions. As we have already seen, the power frequency tests are two types. One is a flash hour test, the other one is a withstand test. Now we will see the first one, flash hour tests, which means that your insulator, you are supposed to identify the voltage at which your insulator will experience a flash hour, and also the maximum voltage which your insulator can withstand. Now we will see. We will take an example now. Let us suppose I take an insulator. Let us suppose it is to operate at 100 kV, and I have designed it, and I am bringing it to practice or to field. Now, if I design that insulator to operate at 100 kV, which means that the withstand voltage may be a little bit higher than the 100 kV. So, if 100 kV is operating voltage, I will design my insulator such that it can withstand a voltage of, let us suppose, 110 kV or so. And even if I apply 110 kV, my insulator will withstand at least for some duration. And if I apply beyond that 110 kV, my insulator may experience a flash hour. So, if I apply 120 kV, the probability of flash hour may be less. If I apply 135 kV, there may be a good amount of flash hour, good probability of. If I apply 150 kV, then it will be a sure shot flash hour. So every time I apply 150 kV, the insulator will experience a flash hour. So like this, I am supposed to identify the different sets of voltages. My 100 kV is operating voltage. So what is a voltage which it can withstand without flash hour? Let us suppose 110 kV. Every time I apply 110 kV, it is not experiencing flash hour, at least for 1 minute or 5 minutes or so. So 110 kV is my withstand voltage. Beyond that, if I apply 120 kV, so 50-50 chances are there. So it is called as 50% flash hour voltage. So beyond that, 150 kV. Every time I apply 150 kV, it is experiencing flash hour. It is called as 100% flash hour voltage. So like that, different ratings will be given for given insulator specimen. Withstand voltage, 50% flash hour voltage, 75% flash hour voltage, 100% flash hour voltage. So I am supposed to test whether these ratings which are given for me are correct or not. So the first one being the flash hour test, which means that I am supposed to check for my flash hour voltage. So if you carefully see the procedure, the AC voltage of power frequency is applied across the insulator and increased at uniform rate of about 2% per second of 75% of the estimated test voltage to such a value that a breakdown occurs along the surface of the insulator. Let us suppose if I am taking again the example, if I take 100 kV as operating voltage. So I will apply first 75 kV Next, from 75 kV onwards, I'll be applying 2 kV per second. To the voltage, I'll be increasing the voltage 2 kV per second. I'll be increasing the voltage to such a level that my insulator experiences a flashover. If the conditions are dry conditions during which the test is being done, it is called as dry flashover test. If the test is conducted under conditions of rain, it is called as wet flashover test. So, specifications are being modified for application of 15 positive and 15 negative impulses. So, 2 in each set are allowed to flashover. If more than 2 flashovers occur in each set, then the insulator is deemed to have failed the test. And next, the wet and dry withstand tests. So, the voltage which is specified in the relevant specification, it is to be applied under dry or wet conditions for a period of 1 minute with an insulator mounted as in service conditions. So, just to replicate the service conditions, the field conditions, the insulator is placed and you are supposed to test it whether it can withstand the voltage, the specified voltage, for a duration of 1 minute. So, after application of voltage till the duration completion of 1 minute, if the insulator has not experienced any damage or flashover or puncture, then the insulator is supposed to have passed the test. So, it is to be repeated in both wet and dry conditions and the same must be recorded. So, wet and dry withstand tests for 1 minute. And next is impulse testing. In the impulse testing also, we do have 2 types. One is a flashover test, the other one is a withstand test. Just like the power frequency voltages, impulse voltage will be applied to the insulators. We will see now impulse flashover test. This test is also done as above, just like the power frequency impulse test with the specified voltages. So, when you are doing this one, the probability of failures, as I have said earlier. So, what is the probability of failure of flashover when I apply this voltage? So, the probability of failure is determined for 40% and 60% failure values, or 20% and 80% failure values, since it will be difficult to perfectly get the 50% flashover value. So, you are supposed to finally mention at least two different values. One is a 50% flashover value, the other one is a 100% flashover value for any given specimen. So, the average of the upper and lower limits of 40 and 60 or 20 and 80, the average will be taken up. And during these tests, the insulator surface should not be damaged by these tests. Only flashovers must be experienced. So, you must see only flashovers, but not any punctures or damage of the insulators. At least most of the surface will be intact. So, small chipping will be okay. Small marking on the surfaces will be okay. They can be subsided. So, major damages must not be there. Not punctures must be there inside. No internal discharges. So, during this test, make sure that small chippings will be there. Your damage must be limited to small chippings. And the same will be repeated for the withstand voltage test, where you will be applying a standard impulse voltage under dry conditions with both positive and negative polarities of the wave. So, impulse voltage, as we have discussed earlier, they will be of 2 types, positive and negative. You are supposed to apply for both. So, if you want to see that your insulator is capable of withstanding your impulse voltage or not, you are supposed to apply that voltage, the specified voltage, for 5 times. If for consecutive 5 times of application of voltage, if there is no flashover, then the insulator is supposed to pass that test. If 2 applications cause flashover, then the object is supposed to have failed. If there is only 1 flashover during these 5 applications, additional 10 applications are to be made and make sure that there is no flashover in the additional